Okay, good afternoon, everyone. Welcome to January's First Friday webinar. My name is Ariana. I'm the Education Specialist with ISPE and today's moderator. Our topic this month is Drones Accuracy and the AEC Industry, presented by Mark Scacco. So Mark, thank you for being here with us. We do have a poll for everyone. I'm going to go ahead and just launch right now. Please answer this if you are able. This is just to help Mark kind of get a better understanding of who's listening so he can optimize his answers to any questions that you may have, which always you can go ahead and type in the questions box on your toolbar and he'll go ahead and answer those at the end. So I just have a few important announcements before we get started. You may have already noticed this year we're trying out a few new processes. One being that immediately following your registration, you are sent to the quiz and handouts page on our website, which is very handy. If you registered yesterday, though, you probably noticed the handouts weren't there yet. They are now. Don't worry. You can head back to that same page and download them there, or you can find them attached to the handouts section of your toolbar. And we're also improving the way that we distribute PDA certificates. So instead of receiving a fillable PDF, you will be sent to a Dropbox folder, which will have your personalized certificate ready to be downloaded. And the best part about this is that we will have all PDA certificates from 2019 and beyond available in the same place. You can now go and download any of your certificates at any time. I will still send you a follow-up email to alert you when your certificate is available with the link to access it, but that link will never change, so keep it handy. Our goal basically is just to eliminate the headache of tracking down your PDHs, and of course, if you guys have any questions about the new process, I'll be happy to help you. So I'm going to end this poll really quick. And just a reminder, please complete your quiz by next Monday, and I'll send an email about certificates in the following week. And with that, I'll go ahead and hand it over to Mark. Mark, it looks like you're muted.
Okay, sorry about that. Welcome everybody to our presentation on drones accuracy and the AEC industry. I do have a question, Ariana, can I see the results of that poll so we can get a gauge on the audience?
Yeah, I'll go ahead and send those in a chat to you right now.
Okay, great. Okay, so while we're looking for that, let me just introduce myself and the company. I'm with RealityOne Midwest. We're located in Downers Grove, but we're also affiliated with RealityOne out in Utah. On this map here, you can see I've got in blue where we have some offices where we've done some work, and the yellow is where we're liking to do work. This map might need to be updated because we've done quite a bit of work recently since this map was last done. I'm the co-founder and the Director of Customer Success for RealityOne Midwest. Our company has many years of industry experience. We have FAA Part 107 pilots on staff. We're IDOT pre-qualified. And together with RealityOne in Utah, we've done over 350 flights in the last 2 years. Just a quick overview of our services, which will probably make more sense at the end of this slide, but provide a broad range of support services to the industry from engineering, volume calculations, construction monitoring, surveys and topos, aerial imagery. Basically, we're trying to provide a full circle services related to drone data capture. So looks like most everyone here is an engineer, which makes sense. But there's also some managers and surveyors and so on the call. So that's good to know. Appreciate you sharing that information. So I'm going to just jump right in. The first question here is why use drones in the first place? Why are we hearing so much about drone usage in the media, as well as in specifically usage is in the AEC industry? Well, there's several reasons. The first has to do with efficiency, and these aren't necessarily in order, but these are the top reasons why they're being used and why our clients are working with drones. capturing large amounts of data in a short amount of time is one of the big benefits of using drones for data capture. On the screen here, I'm looking at we have a aerial imagery of an old steel mill or steel processing plant that's about 130 acres. And this would have taken quite a long time to capture using traditional methods. If you look where I've got that red arrow, I'm just going to zoom in on that area and show you the level of detail and the amount of improvements on this site that will need to be captured. So right where that red arrow is, you can see that there's a whole lot going on there. There's a creek, there's a steel bridge, there's retaining walls, there's overhead pipe supports, there's foundations, lots of information to be captured in that. And you could imagine that a surveyor or field crews out there would take a lot of time to capture all of that. We can capture all of that information very easily using drones. So here is a point cloud captured from that same area, and each one of those points has an XYZ coordinate associated with it. So we can very quickly capture all of that information and then process it down the line. Another example is when there's a lot of flat work or site improvements that need to be captured. On this particular site, the area of interest was the school property here, but the requirements were an overlap extending about 3 houses in each direction. And you can, just by looking at that image, you can see all of the sidewalks and all of the different information there that would need to be collected, not to mention that there's fences to be hopped and all of that to get onto the site to get that information. But we were able to easily capture that and turn that into a finished topographic survey very easily. So efficiency, the ability to very rapidly and accurately capture the data is a big benefit and reason why the AEC industry is looking at drones. Another big reason is safety. There's a couple different examples here. Contaminated sites or soil remediation, that's becoming, not becoming, it has been a big issue over the years, and there's a couple projects that we've worked on here. This is an 800-acre site out in the west that they're moving a huge amount of soil on, and to get an understanding of what's out there and how much has been moved and what needs to be moved, they need a topographic survey. Doing this with the traditional methods would have been hazardous to the surveyors, both from a health point of view, but also from a tripping or slipping point of view. So this was done with drones in a fraction of the time it would have taken, and also keeping the staff safe. Steep terrains. Here's an example of a ravine for which a survey was required. Again, scrambling up and down that hill with a traditional surveying equipment or data collection equipment would be hazardous and not very time efficient. With a drone, we can capture that very easily, and again, keeping our staff safe. And then finally, just hard traffic, highly traveled roads or hard to access areas. This is a site where it was just a cornfield, which was not hazardous, of course, but the surrounding roads were busy, and there's a railroad on the north end of that site in the lower picture. So we were able to capture all the roadway improvements, the railroad, all of that without ever putting a person anywhere near the road or the railroad track. So just some examples there of how safety is used, or how safety can be improved with the use of drones. So how are they being used? We know why they're being used, but how are they being used? One of the big things is, and there's lots of different reasons. I'm just going to touch on a couple of the primary ones that are relevant to this audience and where we focus a lot of our attention. The first is in land surveying. Specifically, we look at data capture for and processing for a preparation of ALTA surveys, as-built or record drawings, and topographic surveys. there's probably not a quicker way to collect the data than with a drone for each of these type of projects. And I've just got some screen captures here of a topo. Here is a site that we have the imagery. There's some new roads that went in, as well as a site internally. And you can see here how that results in a ALTA that was prepared from that data. And here's another, this is a topographic survey with adjacent roads. You can see some buildings in there near the north end of the site. So we can very quickly capture this data and prepare it and deliver it to our clients, which are surveyors for these particular projects, that they can then continue to do their work on it. Next use case we commonly see is earthwork and volume calculations. Whether it's mass earthwork operation, stockpiles, mining, soil remediation, there's really no quicker way to gather this data, but not only gather the data, but also to process it. We can be on site, fly it, capture the data, and process it without ever actually going into Civil 3D or any of your other design applications. We can pull that information out. So here we've got a couple examples. In the upper right is a site that we did some mass earthwork volumes on. Down below, you see a stockpile from that contaminated site that I showed earlier, and the volume calculations and the models on either side of that. Construction monitoring and quality assurance, quality control. We don't do a whole lot of this, but it's becoming more and more popular. In this example here, before the trenches were backfilled on this site, the owner wanted to verify, just to capture the conditions before it was backfilled. We use drones to verify grading. This was a mass earthwork site that had sat for a while. And before the developer went in there to start building homes again, they wanted to make sure, see where the current condition of the mass earthwork was. Another common use is roadway rehab or DOT work. Again, this ties back into the safety issue of being able to collect the data in a safe manner, but also to be able to collect information that would otherwise be very time consuming. Here is a state road for which they were going to do some rehab work. We captured the staging area to the southwest there, as well as the road. Here's a roundabout that went in that we captured. And here is a view of point cloud from that road. One thing to point out is that, first of all, that you can see how detailed the point cloud is, including the striping, details of the signage on the side of the road, manholes, but also the cars. This is a heavily traveled road. It's not just an empty road. The vehicles are stripped away, leaving us with just a clean point cloud. Another common use that kind of bleeds over into the architectural side of things is complex buildings or buildings and complex sites. Being able to capture a lot of data when there's a lot of improvements on the site is a huge advantage to using drones. So here we've got a couple different images that we've captured. There's an industrial building. This was I believe this is the church or a religious facility. Here's a high school campus, and I think that's the same. That is the same picture in the lower left. You can kind of see some of the detail there that would be required and require quite some effort to do it traditionally. And there's a point cloud of that school. So there's a number of different reasons why drones are being used, primarily efficiency, and efficiency applying both to time savings as well as cost savings, and safety, keeping your users or your staff safe. So every time I give this presentation to anyone in our industry, the first question is about accuracy. In fact, that's the name of this presentation. So I wanted to spend some time and really look at that. So what about the accuracy? How accurate is the data that we collect compared to what is used or what's collected with traditional methods? First thing we want to talk about is targeting. When we go to fly a site, we coordinate with the surveyors to make sure that the data can be as accurate as possible. And one of the primary tools that we use to do that is setting ground control points, GCPs. And if anyone in the audience has been around for a little while, you might recall and has worked with any type of aerial imagery in the past, you might recall that the targets for traditional aerial data capture were quite large, the size of 10 by 10 or even larger, 20 by 20, like a bed sheet or a big cross on the ground. That's because the aircraft are flying at very high altitudes. And to be able to capture that, you need a large target. Well, drones fly much lower, between 100 and 400 feet, and therefore our targets can be much smaller too. So what we do is we'll work with the surveyors to set targets at key locations on the site, but these targets are very easy to set. They're small. That you see right there on the screen, that's a 24 by 36 inch plastic, corrugated plastic, like a political yard sign. If there's something on the site that we can use, we'll use that. I'm sorry, I'm getting ahead of myself. Here's a small template that was spray painted on the ground, and just for references, you can see the shadow of the person on the left-hand side, just to give you an idea of how large that is. Very small. We'll use a manhole if that's available, or any other man-made structure. As long as we can see it from the air, we can use that as a target. And if there aren't any hard surfaces or existing items, we will drive a PK nail through one of our targets and use that. After the targets are set, the surveyor will go and shoot these targets with their traditional data collection methods. Typically, the surveyor needs to be on site for boundary work, locating iron pipes or property corners, dipping manholes. There's work that needs to be done on site in addition to what the drones can capture, and we'll try to coordinate that, or we usually will coordinate that work with the collection of the coordinates for the ground control points. So let's look at a couple of examples. Here is a sludge drying pond, about 18 acres. The circles in that image, or in that picture there, show the location where images were taken from the drones, and the blue circles are the ground control points where we can see out, and where the white circles, the filled in white circles, indicate the images that were used to correlate those ground control points with the rest of the data. And in doing this, in correlating this data with the ground control points, we end up with some very tight accuracies. These are pretty tight. Typically, we're getting, in this particular one, we got very tight, 300ths and 400ths of a foot horizontally and vertically, respectively. Typically, we are within the 0.05 to a tenth of a foot range, which is the same accuracy you expect from traditional GPS equipment. We can go back and check this accuracy with the information that's pulled from the drones and the processing software that we use. The software generates a quality check as well as a discrepancy report that shows the differences between what was shot in the field and what we collect for those particular points. Again, this project was very tight, but we can provide a full-blown report showing the actual discrepancy between these points that were shot in the field as well as the ones that we collected. So let's talk about next how the point cloud is created. So first thing we got to talk about is the equipment. The equipment that's used to collect the data. Obviously, we're talking about drones, so we're using drones, and here are some images of drones that we use in our fleet. There's some consumer level drones, but also professional grade drones here. They're all GPS enabled. They all have a high resolution camera, and that might be the difference or a distinguishing factor from what you might currently be familiar with as far as generating point clouds and creating point clouds from LiDAR versus images. So let's talk about that. When you're collecting or creating a point cloud from LiDAR, LiDAR uses a direct measurement, sending a beam of light that then bounces off and is collected and measured with a receptor in the device that's in the LiDAR device. On the left-hand side, we see a single return where the beam of light left the device, bounced off the ground, and was collected. In the image on the right, or the right side of that image, we're getting multiple returns. The light waves can, depending on how dense the coverage is, you'll get multiple returns. So the first return comes from the treetops, and second return comes from lower branches, and the third return comes from the ground. And using the difference in the time it takes for that light beam to return to the receptor, the software can classify these returns and then identify them based on their X, Y, and Z location. So you get multiple classifications, and it makes it easy to strip away items that aren't on the ground and have a clean point cloud. So that's with LiDAR, and there are drones that have LiDAR equipment on them. What's more common though is using photogrammetry, 3D photogrammetry for the point cloud creation. So how are point clouds created from images? So the drone will fly over the entire site, taking hundreds or dozens, hundreds, thousands of pictures, depending on the size of the site. And each of those pictures then is uploaded and processed. And and from those images, a point cloud is created. So on this picture here, we have a bunch of images in which that little turret or tower there shows up. And using computer vision technology, the software goes through and tries to match up pixel for pixel, every pixel in each image. So the tip of that tower there shows up in multiple images, and by correlating those together, the software can determine an X, Y, and Z location for every pixel in the image. And in doing so, we then, from that, get a point cloud. So when you use 3D photogrammetry, you're looking at an intermediary step to get to a point cloud. We first collect it with imagery. The computer processes those images into a point cloud. One of the drawbacks of using photogrammetry is that you don't get multiple returns like you do with LiDAR. So if it's a very densely vegetated site, the drone images cannot penetrate that canopy, and you'll just get the treetops. If it's sparsely vegetated and you can see some of the ground, obviously we can then get ground shots from that. If you look at like a farm field where the corn is planted about 30 inches on center, typically for the rows, as long as the corn is about 2.5 feet tall or less, we can collect that data. I think there was a question from one of the audience members here about that, about thick vegetation. So that's the answer to that question there. The way to think of this is that if you were up in a hot air balloon looking down at the site. If you could see whatever you can see with your binoculars or your naked eye, then that's what the drone will be able to capture. Now, there are techniques that we can use in terms of flight planning, different flight patterns to get underneath the canopy. For example, if we had a tree line along a property line or a stand of trees that wasn't too dense, we can, based on the angle of the camera, we can get underneath the canopy and collect some data. As I mentioned a moment ago, there are drones that have LiDAR equipment on them. They're more expensive than a drone with a camera by an order of several orders of magnitude, anywhere between 25 and 50 times more expensive. So yes, there are drones. That's another question that someone just asked. Can a drone do a LiDAR survey? Yes, it can. It's just it's different equipment that is much more expensive and creates a larger barrier. As far as the accuracy between the point clouds generated by a LiDAR and by 3D photogrammetry, it depends on a couple factors. The height of the flight is a factor, the number of images that are taken, the resolution of the images that are taken. We're getting about 1 pixel per quarter inch with the photogrammetry. If you're looking at a high density laser scanner that's mounted on a tripod, you can typically get tighter than that. So a LiDAR can be more accurate, but it doesn't necessarily by default mean that it's going to be more accurate. There's several factors. So what are the workflows associated with capturing data with drones? Well, and then processing it. Well, first part is the capture. So, and these are just general steps, and I entertain questions on these, of course, as we go through. First thing we need to do before we go on the site, obviously, inspect the site and make sure that it's applicable for use with drones. Like I just got done saying, if it's a heavily wooded site or there are other obstructions, it might not be the best use case for it. But assuming that the site is that using drones to capture the data on the site, the first step would be to set the ground control points. Second step I call preparing the site, but that's just making sure that basically the same thing you would do in a normal survey situation. Make sure that you've called Julie or the utility locators, that if it's a parking lot or a large area or a heavily trafficked area, that the site is clear. Maybe you're doing it on a weekend or when there's less traffic on the site. If it's a farm field with a corn or the vegetation is larger or higher than what can be captured by the drone, you want to wait until harvest. But after the site is prepared, then you need to plan your flights. So there's a couple different software applications available that allow for the planning. They make a lot of noise in the industry and marketing. There's ads everywhere. Can't turn around without hearing about drones. But there's a number of vendors that provide flight planning software. Typically it runs on an iPad or your phone. Some of them allow you to do the planning right via the web interface from your desktop and transfer it to the drone. There's several different flight patterns and approaches for setting up your flight, and that's going to depend on what the actual desired results are. If you're looking at identifying the building footprint, you might have a different flight pattern than you would for collecting a farm field, for example. You also need to have FAA approval, not only from have pilots to fly commercially in the U.S. You need to have an FAA Part 107 pilot's license, but you also need to make sure that the location, the site location that you're flying, is not in restricted airspace, and if it is in restricted airspace, you need to get FAA approval to fly that site. The overall process, the next step in the process is processing. We need to process the data. So when you fly a site, that's kind of the easy part. If there's an easy part to this, flying the site is the easiest, and collecting the data is the easiest part. It's the processing it and turning that data into useful information that can be used downstream is where a lot of the effort goes into, and that's really where we're adding the value, a lot of the value to our customers. The first step is cloud processing. It doesn't actually have to be cloud processing. It's processing the data, but I say cloud processing because you need some pretty serious horsepower on a workstation to be able to crank through these sites. And the larger the data set, the more horsepower your workstation would need. However, most of the vendors out there that provide the flight planning software also provide cloud processing, where you do upload the images directly from the drone to their site, and then their servers will crunch the numbers, crunch the information, do that computer vision, use that technology to match up those pixels and generate not only the point cloud but also an overall ortho mosaic of the site itself. So the result is a clean point cloud and also an overall high resolution image of the site. Once we have that point cloud from the servers, then our semi-automatic or our manual processes kick in, and that is extracting the features and the line work from that point cloud, from those images, and starting to turn this into useful information for topographic surveys, ALTAs, as-builts. After that, after we've extracted the feature lines, created the line work, we will then create surface models. And we use a bunch of, there's several different applications that we apply here to get this done. There's some screen grabs from the cloud processing, from the tools that we use for extracting our feature lines, the ones we use for processing our point clouds, a number of different tools. Once all this is pulled together or extracted from the model, we then compile a CAD file that includes all of the line work and the digital terrain models, and then that becomes the deliverable or the primary deliverable to our clients. They'll get a CAD file in Autodesk or Bentley or Carlson, whatever platform you're using. That will be the deliverable to our clients. Sharing. I just kind of talked about that already. Talked about the CAD file already. So here's a site in Civil 3D. There's line work in there. There's some points shown in there. But basically, like I mentioned, the deliverable are the planimetric features as well as the digital terrain model, COGO points, whatever is required for the deliverable. We also deliver images. Not only is there an overall image of the site, but we also can deliver or do deliver all the individual high resolution images of the site, like I showed way in the beginning of the presentation about that complicated area on that site. One of the really beneficial aspects of that is that you can kind of do a virtual site visit. As engineers, we're supposed to go out on the site and walk it to make sure that we understand what's there before we start designing. But a lot of times we'll miss things, or something might be covered in snow or a car parked somewhere. So having access to the high resolution imagery for the site is a very powerful tool from the designer's point of view to really give you a feel for what's going on out there, especially those coupled with the topographic survey. And then there's a number of other tools that can be used or shared. Volume reports I talked about before. We can very quickly generate volume reports both for mass earthwork, comparing to an existing topographic survey to your design surface. We can generate just simple stockpile or cut volumes. There's also a number of different tools and shareable deliverables that we can share. So the lower image there is the timeliner, and that can show you the progress, comparing the time on a certain date on one side, on the left side of the screen, to a later date on the right side of the screen. So you might be asking, how do we get started, or how do I get into this? Well, I'll give you an outline for that, and of course this is going to be a high-level outline. But the first thing is you need to get buy-in from whoever it is you're working with. There's still some skepticism out in the marketplace, and rightly so. It's a newish technology. There have been some exaggerated claims, both from manufacturers as well as from service providers. So it's important that you and your colleagues understand what drones can and can't do, and get buy-in. The next step is obviously the equipment. Either own or rent it, or outsource the data collection. But you actually need the drone to collect the data. People, I mentioned this before, but you need to have licensed pilots, either on staff or, again, outsourced, hire someone to do that for you. Then the data processing. Once you've collected the data, not only do you need to have either a cloud-based subscription, like I mentioned before. Those are typically billed annually to process the data, process the images, and generate the point clouds and the imagery. Or you could do that in-house with your own workstation. Once you have that information, you're going to also need to have your desktop applications that you use to manipulate the data, the point cloud editing and feature extractions, and of course your CAD applications that most organizations already have. Training, you need to get your staff up to speed, and it's not only the pilots, they'll have been trained or gone through some type of training to fly the drones, but to really understand what it is they're collecting. It's a different type of, you got to make sure that you understand what you're collecting and why you're collecting it in the field, and then also back in the office, just making sure you understand how to use the applications to edit and extract the data from the point cloud. And then once you've got that in place, you're ready to start your first pilot project. Typically, this would be a project, a small project, maybe one that you've already have topographic information on, or that you've collected information on, so you could compare the results that you get from your drone data collection and processing to what was collected and prepared with traditional methods, and determine what worked, what didn't, make adjustments, and then roll into your first real project. So that being said, let's go and look at some of the questions that have been posted. And please type your questions in now, and we will answer those as we go. So one of the first questions here was, will the drone identify Julie marks? Yes. That's the answer. As long as they're visible, like I mentioned before, you can imagine yourself in a hot air balloon, 100 feet off the ground. If you can see the Julie marks, then the drone can collect those, and then when we do our post-processing on that, we can add those to the CAD file just as you would normally. Obviously, the drone isn't going to be pulling manholes and measuring down to inverts or getting pipe sizes, so there is some field work still related to that. It's also not going to be able to go to the county office and do research on maybe things that didn't show up on the Julie or the utility locates. But if it's marked on the ground, whether it's a flag like a paint, like your traditional pavement markings for underground utilities, or flags that you might see for wetland delineation or floodplain delineation, or or utilities. We can pick those up and get those into the deliverable. There's one question here, which is I really won't be able to answer in too much detail, but it's how do you extract the features? There's software available out there that facilitates what I like to call a semi-automatic or semi-manual process, where you can, using the imagery and the point cloud, you can generate feature lines at critical locations. A lot of it is spent just understanding and having the right software tools and understanding how to use them, and what is being presented by the excuse me, what is being presented by the point cloud and the imagery. I'm just going to read some of these questions here and see which ones I can answer. So there's a question here. I'm going to ask for whoever asked this to provide some additional, to clarify. Please discuss adding ground survey details to point cloud when higher level of accuracy is required. Please clarify what you mean by high level of accuracy. We're looking at an accuracy that that is on level or on par with a GPS type survey. If you need additional accuracy greater than that, the data can be combined. You can do ground shots, you can do your traditional equipment, and add that into the same CAD file that from which you've added, or to which you've added your drone captured data, and that just all becomes data that can be used to build the surface or identify the planimetric features. If that doesn't answer your question, please clarify what else you'd like me to answer there. This question is similar to the other one. How much effort do you typically have in editing the point cloud to extract the feature lines? Is there a tool that can automate the process? I answered that to my best of ability right now, but there is some effort required, and it's not just push a button and have the job done, but it does. But it is once you are capable with the software and understand what you're looking for, it's not a task that's insurmountable. All right. Would you describe an accident you might have had? Knock on wood, none so far, although we've had a couple drones go down due to bad weather or microbursts of wind and things like that that would knock a drone out of the air. But typically we won't fly in inclement conditions. We don't fly in the rain. If it's too cold, we can still fly, but we can fly. If it's windy, we can also fly, but it depends on how windy it is. But luckily, we've had no accidents that to speak of. That being said, we do carry probably more insurance than I have on my cars, but we haven't had to use it. Okay, so processing point clouds. Do you use point clouds or reality meshes produced by the software? For example, context capture. I know what context capture is. I'm not familiar with the reality meshes that it creates, but we're working with a point cloud. In some of our software, we're working with just the point cloud. In others, we have an image draped on the point cloud. So it's a combination of both. And I believe the reality mesh sounds a little bit like that latter of the two. But it's a combination of both, using the imagery and the point cloud in conjunction to pull out the features that are needed. Can you clarify the accuracy of the data? I believe you indicated a range of 0.5 to 1/10 of a foot. One of the figures listed an accuracy of 0.2 feet. So in general, a random spot out in the middle of the field or on a parking lot is going to be in that 0.5 to 1/10 of a foot range. When we're tying our data together with the ground control points, those particular points can get a lot tighter. Because we know those elevations and we correlate at those particular locations. But in general, we're talking about a 5/100th to 1/10 of a foot, and on average, we're getting closer to the 5/100th of a foot than to the 1/10 of a foot. Can other sensors such as infrared be attached to the drones? Depends on the platform, depends on the drone. The short answer is yes, they can. Some of the consumer level drones have a fixed camera, which isn't removable, but others have the ability to swap out the sensor so that you can put in an infrared camera, you could put on a different type of optical camera. So yes, the answer is yes to that, depending on the drone. Can you review what the Part 107 license is required for? To fly a drone commercially in the United States, you need to be a FAA Part 107 licensed pilot. So if you're going to use this for work, you need to have a pilot's license. All right. It looks like that's the last question.
Yep, it looks like the questions have slowed down, so I think it's safe to say we can call it now. Mark, I just want to thank you for a great presentation, and thanks for everyone who joined in today. I do want to mention we still have some openings for First Friday presentations. If you're interested in speaking, just go ahead and send me an email and we can talk about details. That's all I have. Thank you again, Mark, and thanks everyone, and have a great weekend.
Thank you.